Okay, welcome to this third class. We're going to start with a building to modulate in order to test the tools to creating geometry in OpenStudio. But as you can see, it could be some complex, some spaces. Not every time you can use rectangles to create your spaces, so sometimes you need backup from another software. In this case, I'm using CAD, but with the ezdxf files, it's easy to import spaces from a Revit file. For example, you could export ezdxf and you can select that the spaces are created as polylines, and this is going to be easy the way to generate the floors, because polylines has to be sequenced, so it's necessary that the points has to be saved in the order that is traced the polyline. If you don't know what is a polyline, it's just a set of lines that are linked one each other. So when I'm using CAD and I start with a layer, for example, in this case I'm using the layer m-enter-zone-n, and I can use a command named polyline, and start drawing my space. And finally, when I want to close my space, I can use the command close. So now I have a common set of points that are saved with the sequence that I was drawing these points, and I can use this polyline to create my geometry in Revit, because all this point has a coordinate in CAD. So I'm going to have two files, one for the ground floor and one for the upper floor, and it's going to import these geometries to our OpenStudio model. Okay, for this class I'm going to use the notebook of Jupyter. I'm going to import the OpenStudio package and our function to create our space, the function that we create the past class. Now we're going to create our model, OSM equals OpenStudio model. Now all these things we have created previously. So the second package that we're going to need for this project is named ezdxf, and you can install it by typing pip install ezdxf. Now I'm going to import this package, and to call the model space of a file, I just have to use this command. And let's going to import the ground floor. So ground floor is equals to ezdx.read file. Now the name of our file, remember that I'm using the same location for my notebook and my DXF file. Otherwise I have to use the directory when I've saved this file. Now I'm going to use uf.gf.dxf, and I'm going to get the model space of that DXF file. Now that I have the model space, I need to query all the polylines and save it as a file. So I'm going to use this command, lines ground floor, where I'm going to save it, and ground floor dot query, and use this command, polyline where layer is equals, and remember the name of our layer, M, Enter, Sun, M. If you name the layer with other name, you have to type it here correctly. Now I close, and now I have all the polylines in this object. If I use for plane in planes, you will notice that I can print all the planes that are inside my model space. And this is a name that CAD uses for each polyline. But where are the location of my vertices in my polyline? Well, this is like a list. So if, for example, I use this command, I'm going to find the first polyline in my model space. And if I add a second coordinate, I'm going to find the first vertex of that polyline. And you can find here the x coordinate, the y coordinate, and the z coordinate. So it's just needed another one, 0 to the x coordinate, and a 1 for the y coordinate. So I can create a for loop to create my vertex by saving an empty list. Now I have 3 cases that my polyline only has 2 points. I can create a surface with only 2 points. So if length of my plane is less than 3, I skip that polyline. Now the second case is that I have repeated points, and that's not allowed for create a surface in OpenStudio. Actually, the program collapses if you create a repeated point. So for avoid this, let's going to use a for point in plane, and let's going to create our vertex. So vertex is equals to a list of point 0, comma point 1, and my level in z, so is 0 in this case, is the ground floor, and if that vertex not in vertex, then I append that vertex in my list. And the last case is that my order of my vertices are not clockwise. Remember that to create my floor, I have to get sure that it's clockwise. So I need a function. I need some function that when if not clockwise our vertex, then I reverse the order. Now I'm going to use this function from Ladybug geometry, and you could realize that when the area is less than 0, then it's clockwise. How to find the area? With this function. So let's going to modify these functions and create a special function in our code to establish if it's clockwise our vertex. This is the function merged from Ladybug, and now we could proceed with the last part, that is create our space in our model. But how are we going to name it? Because if you notice, our polyline doesn't recognize the name of the space. Well, in this point we could make later with some dictionary that translate every polyline with the name of our space, but for this class and for this video I'm going to use a space name that is a fusion from our level and the name of our polyline. And to get that name, we could use the function line.dxf.handle. Now let's going to call our function. We're going to get the points with vertices. The height, we're going to assume that is 3. The model is OSM, and our space name is our space name here, the same space name. If you are confused, let's going to name it here, for example, a space name with an N to understand. And this is the space name. Now let's going to name our OSM file, so osm.save model.osm. Now if we open our file, we're gonna find here geometry, and there it is, the geometry of our ground floor. Now let's going to create our upper floor. Let's going to name upper floor to get our model space, upper flow, lines are going to be a query, and here I'm going to use a 4 for upper floor, and the z coordinate is going to be 3 because that was the height of the first level. The namespace is going to be upper floor, and let's going to run and save the model. So that's all. We have created our space building using just code and the CAD files that, as I said before, you could obtain it from Revit or from your CAD program, the one that you use, and it's going to make a little bit easy the way you create each floor. Now, if you have to create these CAD files, you have to take care about the coordinate and the round of your points in order to have a precise model.